Hi student, this is Sivakumar. 11th standard mathematics, chapter number 5, continuation of exercise 5.1. Now problem number 9. If n is a positive integer, show that 9 power n plus 1 minus 8n minus 9 is always divisible by 64. Now this is question number 9. We have to show that this expression is always divisible by 64. We have to prove this expression is equal to a multiple of 64. Multiple of 64 means that is divisible by 64 only. Right? Now consider nine power n plus 1. 9 itself we can write 1 plus 8 or 8 plus 1. I write 1 plus 8 whole power n plus 1. Now this is of the form a plus b power n. Here we have n plus 1 in the power. Listen carefully. Here n plus 1 c0 double set of brackets, n plus 1 c1 double set of brackets, n plus 1 c2 double set of brackets. It is going on up to n plus 1 c n plus 1, then double set of brackets. Starts with n plus 1 c0 and ends with n plus 1 c n plus 1. Here we have a and b 1 and 8, right? 1 and 8. 1 and 8, 1 and 8. Here also 1 and 8. Now the power is n plus 1. Write n plus 1 here. Keep on reducing 1. If you reduce 1, n plus 1 becomes n. If you reduce 1, n becomes n minus 1. It is going on. The last one will be 0. Like that, here you start n plus 1 in the power. This is n plus 1. Then it will be 2, 1 and 0. That is equal to, we know that if the suffix is 0, n c0 value is 1, therefore n plus 1 c0 value also 1. 1 power anything is always 1. Anything power 0, that is 1. Plus n c1, that is equal to n, therefore n plus 1 c1 is n plus 1. 1 power anything is always 1. 8 power 1 is 8. Plus n plus 1 c2, n plus 1 c2, right as it is. 1 power anything is always 1 and 8 power 2, that is equal to 64. It is going on up to ncn. If n and r are same, that is equal to 1. Therefore n plus 1 c n plus 1, that is also 1. 1 power 0, that is 1 and 8 power n plus 1. That is equal to, if you multiply, you will be getting 1 plus n plus 1 into 1 into 8, that is n plus 1 into 8 plus 1 into 64, 64 into n plus 1 c2, n plus 1 c2 into 64, etc. up to 1 into 1, 1, 1 into 8 power n plus 1, that is 8 power n plus 1. Okay. Here write 1 plus, and this is one more step, n plus 1 into 8, that is n plus 1 c2 into 64. Even you can write 8 square, that will be convenient for you, 8 square. The next term of n plus 1 c2 will be, I write over here, n plus 1 c3, it will be 8 cube. 8 cube. Next one 8 power 4, 8 power 5 is going on. The last one is 8 power n plus 1. Now write this one as it is. 8 into n, 8n. 8 ones are 8. Here write 8 square. Here 8 cube. From here to there I take that 8 square as common. So this is the least one, 8 square, 8 cube, 8 power n plus 1. So I take 8 square as common. If we take 8 square as common, we will be getting n plus 1 c2. n plus 1 c2. We have taken 8 square already common. plus n plus 1 C3 will be there, n plus 1 C3 will be there. We have taken already 8 square common, so only 8 will be there, plus here we have taken 8 square as common. You will be getting 8 power n minus 1 at the power. See, if you multiply here, 8 square will be there, 8 square into 8, 8 will be there. If you multiply, just add the powers, 2 here, n minus 1 here, add the powers, 2 plus n minus 1, that is equal to n plus 1. Here it is. So what will be here? 8 power n minus 1. Which implies, what is in the left hand side? 9 power n plus 1, which implies 9 power n plus 1, right as it is, 1 plus 8, that is 9. Before that, plus 8n comes left hand side minus 8n. 1 plus 8, 9 comes left hand side minus 9. That is equal to, what is 8 square? 8 square value is 64 into the entire expression I consider as the constant k. Definitely you'll be getting one value. That value I consider as k. K is a constant. Look at that. I have proved that 9 power n plus 1 minus 8n minus 9, that is a multiple of 64. 64 into any number or 64 into any expression is a multiple of 64. Even we can say that is divisible by 64. Okay. Therefore, finally write the result. 9 power n plus 1 minus 8n minus 9 is divisible by 64. So problem number 9 is completed. Then I will be teaching the problem number 10 in the next video. Thank you, children.